Today we're going to be taking a look at what are called inequalities. We're going to be specifically looking at how to solve inequalities when we have to add or subtract. What you'll notice is that when we're going through this, it's very, very similar to what we did when we were solving equations, but there's going to be one significant difference. So let's go ahead and take a look at this. First off, we've got a few symbols you may not have seen before. First off, we have these open V looking things, and we have open V's with little lines underneath. When it opens up to the right side, when it opens up to the left side, the bigger side's over here, this means greater than. Specifically, whatever is over here is greater than or bigger than whatever is over here on the right side. If it opens up the other direction, it means less than. So whatever we have on the left is less than whatever we have on the right. And we'll take a look at some examples of these in equations in just a second here. We also have greater than or equal to, and we have less than or equal to. So we've got these four symbols here that we're going to be using in our equations. So make sure that you have these in your notes. All right, this is an example of what an inequality looks like. So the way that you would read this is x is greater than or equal to 70. That means that x can be any number that is bigger or equal to 70. For instance, the way we may use this, you need a 70% to pass my class. It doesn't matter what grade you have as long as it's a 70 or above. So your grade, or x, can be any number bigger than or equal to 70. It could be 75, it could be 90, it could be 70. Any one of these numbers is greater than or equal to 70, just like we have here in our inequality. When we are solving an inequality, all of our rules for solving equations can be used for inequalities. So if you remember your rules for solving equations, which hopefully you do, you can use these same rules when solving inequalities. Let's take a look at a couple examples. So here we've got x minus 4 is greater than 12. So if I were solving this as an equation, you might say, okay, well I know I need to cancel out this negative 4 here to get x by itself. We're going to do the same thing with the inequality. We're going to cancel out this negative 4. So to do that, remember we need to do our inverse operations. We need to add 4 to both sides. So here these two 4's cancel. We're just left with x. 12 plus 4 goes to 16. And then our inequality sign just comes down. We don't change which direction it's pointing. It stays pointing in the same direction. When we get into multiplying and dividing, you will see that there is one time when our sign changes direction. But for the moment, our sign is always going to stay pointing in the same direction. So this is our answer. X is greater than 16. So x can be any number that is bigger than 16, but since we don't have the line underneath, it can't be equal to 16. Here for the second problem, we have 2 is less than 5 plus x. So I want to cancel out this 5 that's on the right side over here in order to get the x by itself. So I'm going to subtract 5 from both sides. These cancel. We just have x on the right side. And then 2 minus 5 will give us negative 3. Once again, we just bring down our sign. So we see that negative 3 is less than x. Or another way of saying it is x is bigger than negative 3. You can read it both directions, but if you read it one direction, you've got to change what your sign means. So if I say negative 3 is less than x, if I read it backwards, I would just have to say x is greater than negative 3.